In previous years, when we're doing mathematical work involving circles, we focused really on properties associated with them. So that's circle geometry involving lines within them or lines outside them, area of a circle, circumference of a circle, arc length, and the area of a sector. What we're going to do at this level at higher is we're going to take this a little bit further. We've never discussed how do we write the equation of a circle down. We've looked at how we sketch it, yeah, but how can I actually physically get the equation of a circle? So what we're going to do is we're going to start to think about representing a circle and how we can work with them. The easiest way to start thinking about this and thinking about how we represent circles is to take the example of a circle in a two-dimensional plane where the center of the circle is located at the origin. So a scenario like this. So we've got a circle here, center located at the origin at this point here. Now, what we don't know is the radius of the circle at the moment, but you could imagine I take from the center at the origin and a line to a point P on the circle. That there's our radius. Now, we can calculate the radius based on the position of this point P. We can create a little right angled triangle here where the length along here is given by the x coordinate and the height is given by the y coordinate. I can then use that to get an equation that gives me my radius. If we use Pythagoras, we know that the radius then is equal to the square root of x squared plus y squared. So what that gives me is if I use this and I change the point, so I move this point to here instead, I'll have a different x and a y, but I'll be able to plug them into this equation and get the exact same radius because the x will change and the y will change to compensate each other. I can then take this point here and do the exact same with a different x and a y. I can then take this point here and do the exact same with another x and y, and I can do it for any point around the circle at that radius from the center. What this allows me then to do is take this equation and write it as x squared plus y squared equals r squared. In here, the x and the y represent a point somewhere on the circle, and the r represents the radius. This here is the equation of a circle with a center at 0, 0, i.e. its center is the origin. And this works for any circle in that case. So a couple of examples for you, I'll show you what I mean. Imagine I've got a circle, center 0, 0, and a radius of 5 centimeters. I want to write down the equation of that circle. Well, our center is 0, 0, our radius is 5, so we know r equals 5. So if I do r squared, that's equal to 25. Now we said before that the equation was x squared plus y squared equals r squared. So in this case, x squared plus y squared equals 5. So any point on that circle, you can imagine I take it and I sketch it out here. I've got my circle going here, and my radius there is 5. What that means is I can represent any point on here, and if I take the radius from the center to that point anywhere on the circle, my radius will be 5. So it lets me get a series of points going around here which represent a circular shape, i.e. this circle here. I've got the same sort of idea here with this one. The only difference is I've given you a specific point on the circle, the 6, negative 8, and I want to know the equation of the circle passing through that point, and its center is the origin. Well, think about it this way. Best bet sometimes is to use a diagram. I've got the point here, 6, negative 8. And I want to represent a circle which passes through that point. So you can imagine, this is the circle I'm looking to represent. Well, in order to represent that, if I calculate the radius here, r, of the circle to that point from the origin out to there, that radius there is the radius I'll use at any point on the circle to be able to calculate the coordinate I'm at, i.e. I'll be able to calculate any point in this circular shape with this radius, and that will be the equation of my circle. So the first thing I have to do is calculate the radius. Now, imagine I take it like a little right angled triangle. That's my radius. That there is the point 6, negative 8. Now I've turned this up just so it looks a little bit different, and it looks a little bit more straightforward and easy for people to understand. Some people prefer to work this way. Well, if this is the point 6, negative 8, that there's your x and that there's your y. The distance there is 8. So I can calculate my radius squared from this. Because I know r squared equals x squared plus y squared, which is equal to 6 squared plus 8 squared. 6 squared, 6 6 are 36, 8 8s are 64, so it's equal to 100. So I know that r squared is equal to 100. Now here you would normally think, right, take the square root, that gives me my radius. You could do that and that would tell you the distance here, but remember the form of the equation is x squared plus y squared equals r squared. We want the r squared, so we're as well actually just leaving it in this form here and writing it as x squared plus y squared equals 100. Now this will give me any point on this circle that also passes through this point here at 6, negative 8. We can represent it like that. Any circle with a centre at the origin, this is the equation we do. But here's a question for you. What do we do if the centre isn't at the origin? How do we take that into account and how do we compensate for that? Well, let's imagine I've got this here. So I've got a circle, a generic centre C, which I'm going to locate at the points A and B, and I've got a point P on the edge. Again, we know that there's a radius. And again, we can set and represent a little right-angled triangle, which we can use to represent this system here. Now, I could take this point P and rotate it anywhere around the edge of this circle. Again, it's going to give us a set of geometric points which will match and represent this circle if they all have the same radius, they all have the same r. So in order to do that, I now need to figure out these two sides of the triangle. Well, let's draw it here so we've got a bit more space. There's my r. Now going along here, this distance would have been x if the centre was 0. But so far I'm starting at A in the x direction and I'm going along to x. So I need to get rid of this part here first. So the base of the triangle is going to be x minus a. Similarly to the y, I've gone up and started at b. I'm going up to y, so I need to compensate and get rid of this wee section here. So it's going to be y minus b. So to do this now, what I have to do is use Pythagoras again for the same sort of result. So I do x minus a squared plus y minus b squared equals r squared. This here gives us the equation of our circle. We could take any centre point AB, plug it in here and calculate the radius we're after, and it'll give us a geometric representation of a set of points in a circular shape all located at that distance r from the centre. This here is your equation of a circle with a centre of AB, so some generic centre which isn't the origin. Now it would actually work for the origin. If you think about it, for the origin, the centre C would be at 0, 0, substitute those in and we get x squared y squared. So it disappears there. So actually it does work for that. So if you want to think of it in terms of this for any circle, great. But any generic point AB, put it in here and you get the equation of your circle with the radius r squared. Let me show you a couple of examples of this. Write down the equation of the circle with centre 3, 4 and a radius of 2. Now remember, it's x minus a squared plus y minus b squared equals r squared. That's the equation of our circle. We need to figure out what the a, the b and the r is. Well, the a is the x part of the coordinate, the b is the y part of the coordinate, and we know from the chat that r is equal to 2. So we have to plug it all in here and see what we get. So if I plug in the a, I get x minus 3 squared plus y minus 4 squared equals r squared, so it equals 2 squared. I then make sure I take this and I square it. Don't ever leave this as 2 squared or something squared. Always square it and get the numerical value you want in that bit. So in this case it would be x minus 3 squared plus y minus 4 squared equals 4. That there is the equation of the circle located at a centre 3, 4 with a radius of 2. That there is what we're after. Second one is write the equation of a circle with a centre of negative 1, 6 passing through the point 1, 9. So again, think of it this way. If I've got a geometric representation of it, my centre here is at negative 1, 6, so it's about there. I've got the point 1, 9, which is up there, and I've got a circle that does that, and I have to get it. So I have to get what the equation of that one is. So there's my 1, 9, and there's my negative 1, 6. So I want to figure out what this radius is here, which we know how to do based on this equation, and then once I've done that, I can plug all the parts in together. So I know in this case that r squared is x minus a. X and y come from the point, so x and y come from this, and the a and b still come from the centre. So in this case, r squared equals x, which is 1. It would be take away negative 1 because that's a squared, plus the y, which is 9, take away the b, which is 6 squared. Once I've got this and I calculate it, I'll get what my r squared is. So r squared, 1 minus minus 1 is 2, so I get 2 squared, plus 9 minus 6 is 3 squared. So I know then that r squared, 2 squared is 4, 3 squared is 9, 4 plus 9 is 13. So I know that r squared is equal to 13. Now again, the equation wants r squared in it. So I can actually just leave it here as r squared equals 13. I don't have to worry about taking the square root at this point because this would be more useful to me. Because now I take my general equation, so I take my generic equation, my x minus a squared, y minus b squared equals r squared, and I plug the information in. The a and b come from the centre, so again the a and b come from here. A is negative 1 and b is 6, and my r squared I've just calculated is 13. So I've got x take away negative 1 squared plus y take away 6 squared equals 13. Fix this bit here with the symbols, so the minus minus becomes a plus. So I get x plus 1 squared plus y minus 6 squared equals 13. That there's the equation of this circle with a centre of negative 1, 6 that passes through that point. It gives me any circular shape that does that with that radius through that point. Bear that in mind. That's how you have to think about it. It's not a set equation in terms of, i.e., a shape. It will not be, I'm going to give you a pi and a d to get the circle. It's a geometric representation of a set of points at that radius where essentially it's twirled round in a 360-degree shape to give you the geometric representation of a circle. Think of it like that. It actually works quite well in your head when you get your head around it. And remember that this x minus a squared plus y minus b squared equals r squared for any generic centre AB. That is how we represent it. That is the equation of your circle with any generic centre and its radius.